Acha, then we move to the next level here. In this situation, this is a very annoying kind of a situation. You have both the terms which are going to be the badmash ones. Now this is ex, and suppose this is cos x. Now, none of them is a character or is a person or is a expression that can be removed through differentiation. They can all be differentiated infinite times. Okay, so this is there is no choice. So you can keep any one of them as u, and any one of them can be kept as v dash. So since it's a longer method, so you just stick to the one. Whatever you keep as u, that will remain u throughout. You can't switch them. Okay, so now right now this is something that we're doing in our mind, that u is going to be e raised to power x and v dash is going to be cos x. Now this is very important to name this as integral I over here. Okay, and again this I does not stand for intizar. This is just this stands for integral over here. Okay, so now we start its integration. So you will find out that why do we need to keep this, why this is important to keep this as I over here. Now, this ex u remains as it is, and you write its integral, that is going to be sine x, and then minus. Okay, now you write its derivative. This is going to be e raised to power x. I have just taken this a simple example here, ex, and then again cos x integral is going to be sine x. Okay, so u dash is e raised to power x and v is going to be sine x. That is what we have done here. Okay, we move to the next step. You see that this annoying product is still there. So we have to try this integrate again by parts. So this is there is nothing, no more simplification for this, because this is, there is no sign like of either differentiating it or integrating it. So this remains as it is. Now we shall apply the integration by parts on this. So this e raised to x comes as it is, and integral of sine x is going to be minus cos x. Now minus e raised to x derivative is e raised to x, and integral of sine x is minus cos x dx. So we simplify this a bit. This is e raised to power x sine x minus plus e raised to power x cos x. Minus into minus will keep it as minus. So this is e raised to power x cos x. Now at this level, you need to stop here, and you see that something which was named as I over here, like, you know, the point from where we started, we have achieved something same as here in our integral. It is the same as that I. So I am going to change this expression with I over here. That is why naming this is very important here for the kind of expressions where both of them can be integrated or differentiated n times or infinite times. This is e raised to power x cos x, and I'll say this is going to be minus I. So this minus I goes to the other side, so this is going to be 2I, and I can take e raised to x common. This is just a simplification. You can do it. You if you don't want to, don't do that. So this is going to be I is equal to half e raised to power x sine x plus cos x, and at this stage you can write your plus c. So did you see that here, like both these characters, they were not going to go away, so we had to, like, you know, apply this method, naming this, and then okay, now just one last thing, and then these notes will be completed. Now in this, you have to integrate something like you have ln x, and in your further maths you will be integrating tan hyperbolic inverse of x or sine inverse of x, that we can't integrate directly. Now this is ln x. We can integrate e raised to power x. We can differentiate ln x, but there is no direct way of integrating this ln x. So for such cases, what will you do? You will just write a 1 with this. So you will just write here, like, this is 1 times ln x. Okay. Now, since we don't know this ln x, how to integrate this, so this will be our u. This ln x will be u. Okay. And this 1 will be our v dash. Because when you integrate this, you will be getting x. And you know that if you differentiate ln x, you get 1 over x. Okay. So here this u comes as it is, and integral of 1 is going to be x minus. Now, the derivative of this u dash, because you remember you should write this formula somewhere, like, the integral of uv dash is uv minus u dash v. Just write this as many times as you can. Okay. So here it is u dash. So ln x derivative is going to be 1 over x, and 1's integral is going to be x. So this is going to be x ln x. They are cancelled out. You're just left with 1 over here. So integral of 1 is going to be x. So that is how you will be getting the integral of ln x through the integration by parts. Okay. So up to this, these are the limits for the A-level mathematics, and we will be going beyond this in our further mathematics. Okay.